Hi, Viper Chemistry students. Let's take another look at molar mass. This idea of molar mass, and just kind of keep in mind that in stoichiometry, we're trying to find how much of something. So it's very convenient for a chemist or biologist to, you know, talk in terms of grams of a product, from maybe the set amount of grams from a reactant, for example. But anyway, molar mass becomes an important skill to master, as we're going through this unit on stoichiometry. So let's kind of develop that idea. So I kind of gone over this before, but when you have a compound such as aluminum oxide, and there are two aluminum atoms and three oxygen atoms in that compound, then you can break it down. For example, the two aluminums, the total amount of mass is the two aluminum atoms times their aluminum's atomic mass value. Now, when we look at the periodic table, we see in each box of each element, um, such as aluminum, for example, that we would see a number that represents the atomic number, and that number is just strictly the number of protons. Whereas the second number is the what we call the atomic mass. Now remember, that's an average value of all the isotopes of each element. But when we get into this idea of working with moles, then we're saying that 1 mole is Avogadro's number of things, 6.02 times 10 to the 23rd number of things. That's a mole. And then that equates to the gram value of whatever the atomic mass value is for that element. So aluminum is 26.98 on the periodic table. That's its atomic mass, but that also equates to 26.98 grams per mole. But there's two of them, so we got to multiply that times two. And then there were three oxygens, and oxygen here has been rounded to 16. And so 3 times that is 48. And then just by adding them up, you get the formula of aluminum oxide, get that formula mass, the formula mass per mole of aluminum oxide. Let's see if there's another one here. Okay. Now, all of this is based off of what they learned from carbon. So originally, when they were investigating this, it turns out that 1 mole of carbon is 12.01 grams. Okay, so that's where that comes from. Now, if we were to look at this particular example, calcium hydroxide, notice that OH hydroxide, which is a -1 polyatomic ion, you would need two of those, and that's why we have the parentheses here with the subscript 2, because calcium's atomic its ion is +2. Okay, so it's a cation +2. Hydroxide here is a -1 polyatomic ion, and it's an anion. Now, put parentheses around that means we've got two of those. So that's why here you see 1 calcium, 1 times the 40.08 atomic mass of calcium. But then you see 2 times, so this is 2 times the oxygen of 16, gives you 32. And 2 times the hydrogen of 1.01 gives you 2.02. Now, adding all those up results in the formula mass, molar mass of calcium hydroxide. Okay, so when you're working with molar mass, you're looking for the total amount of mass in grams of each individual element and the number of each element that's in that formula. Okay, all right, hope that helps, and good luck.